Okay. So today we will continue with another chapters. This is already week 5, Okay, so fast, You remember week 10 is your written test. I'm not so sure whether this class, of course this class is full, but I want to make it alternate sitting. So if let's say we cannot do alternate sitting, so maybe I need to change the venue to another venue for this class, because your written test will be your written test will be during the lecture. Okay, so week 10. Okay, up to now, I hope that you know, okay, how to do the state space schema. Okay, you should already started to do that by last week. Okay, and then this week actually you have to start with operation schema. Maybe you can start with CRUD first, because that is the one that in the tutorial whatever we go for, like add, remove, all those things. So that one more on the CRUD. Okay, so you can start with your operation schema this week. Okay, so the next chapter, okay, is actually about how you are going to structure your Z. Okay, before this, what you learn normally, your declaration is only one type. Okay, but in one of the tutorial, okay, I actually introduce a little bit about Cartesian product. Okay, one of the question from if I'm not mistaken, is tutorial 3, okay, about Cartesian product, where you use X, okay, in order for you to look at the data. So Cartesian product is the one that minimum to show relationship in your Z schema. But we will not stop there, okay, with Cartesian product, because you are going to improve your Z schema with another relationship, okay? Because the one that you, most of you may draw ER diagram. So when you draw ER diagram, you have multiplicity where you have one to many, many to many, okay, one to one, and so on. So Cartesian product cannot show this one. Okay, so you are going to use another structure, okay, to show all this. So this will be covered in this chapter. Clear? So what I will discuss again is about tuples. So this is the one that you are going to use Cartesian product, okay, relation and function under this chapter. We will have also what we call as extended, okay, extended Z structure, where you are going to learn about sequence and backs later. Okay, but for this chapter, we are going to concentrate on relation and also function. Mostly about this. Okay, so before this, when you declare your variable, normally I will just teach you, let's say name, power set, name, like that only, So one type. So if you do that in your state space schema, let's say you have ID, power set ID, name, power set name, and then email, power set email, all these are actually individually not connected. You are doing this as individual, but these are not connected with each other. Meaning that it's similar, like you have different table, one for ID, one for name, one for email. Okay, whereas in our, for example, our database, all these three things are actually connected as record. For example, records of maybe students or staff and so on. So in order for you to do that, okay, what you did during your Cartesian product, you group or you combine together, make it a pair. Okay, so let's say one of the questions in your tutorial is to combine employee and the salary and so on. So you combine as a pair. Okay, so this is where you learn Cartesian product. So you combine. When you combine as a pair, you link. Let's say ID with the name, ID with the email, you link the table together. So when you search through ID, you can get the name. When you search the ID also, you can get the email, for example. So you are linking the table together. Okay, So when you have like that, okay, in Z schema using Cartesian product, we call that as tuples. Okay, the one that you did in your tutorial is as a pair, but tuples you can do more. You can do triples, you can do quadruples, 5, 6, 7, whatever, you can do that. Especially if you want to show, display the result. So you want to choose, you want to have name, you want to have email, you want to have this. Let's say 5 things that you want to show that. So other than that, you don't want to show. So rather than you use individually, then you can combine the output as Cartesian product, as a record lah. Means that in similar like you produce a monthly report, whatever, you have column. So these are the things that you can use Cartesian product. Okay, you can use Cartesian product. So this topic or this chapter will cover these 3 things only. Then the sequence and back we will cover in another chapter. Okay, so like I told you just now, okay, tuples, okay, you can have pair, triple, quadruple, and so on. So what we mean by pair means you have 2 data only. Combine 2 data as a record. If triple mean 3, quadruple mean 4, and so on. So means that when you call the record, it's actually a combination. If it is a pair, it's a combination of 2 already. So you don't, you don't retrieve one by one. Okay, so if it is quadruple, the data inside there is actually in 3 already. If quadruple, 4, and so on. Okay, so means the data there, the record is actually consists of 2, 3, 4, 5. It's up to how you want to show inside your Z schema. Okay, so but mostly when we do our Z schema, my suggestion is a normal, not printing, not display the output, a normal for you to retrieve the information from database and so on. I will suggest you to go for a pair only. Okay, not quadruple, not 5, 6, 7, and so on. We are not going to go for that. We are going to go for a pair only. Okay, so this is actually how you do with your Cartesian product. Means that assuming that you have types here, okay, you have basic type. This is actually if you want to rename, okay, let's say not rename, means that you want to use ID as n, but normally ID will be a string lah, basic type. This one is I just want to show that if let's say you have, some of you want to have amount, the keyword amount, amount, not n. So in order for you to do that, you can do amount double equal n. Means that it's similar like you are giving a nickname for your n as amount. So means that in your state space, in your operation schema, you can use the keyword amount rather than n. But for me, I will suggest you to, normally I will ask you, this amount is it n or string or basic type? If basic type, cannot. If you put equal n here, meaning that it is n, so can. So how you want to do, make sure that you refer back to your basic type and also your free type and so on. If you declare amount inside the square bracket, that is a string, cannot. Okay, so if you want to represent as n, you have to put amount equal n. So that one means you are giving a new name, okay, amount, okay, rather than you want to use n. Okay, so that is another way. And then this one is a free type. I think all of you have done in your assignment for data abstraction. Okay, so you have list down all your basic type, all your free type, and also maybe you have axiomatic definition. Then you have done during data abstraction week. Okay, and then if let's say, okay, you want to be your data to be specific. Maybe some of you, you want to put date. Some of you just put date, right? But some of you want to have specific format. So the specific format, you can do something like this, Cartesian product. Okay, for example, date, day, month, year. Okay, so you can have day, month, year here. But of course here, day, month, year, you have to declare here first. Okay, you have to declare on top whether string or and or whatever. Okay, so you have to define first. You cannot simply put date equal day, month, year without telling what is the type for it. Okay, so if you want to have day, month, year as normally for month you can do free type. Okay, 1, 2, 3, 4, 5 and so on. For day also you can have 1, 2, 3 until 31. Free type, you can do that. And then for year maybe n. Okay, it's up to you. Maybe you want to have free type, but normally no lah. For free type normally we go for n. Okay, so you can have that. So you define on top before you use as the Cartesian product. So this one is triple. Means that your data, when you receive the data, it is in 3 comma lah. Means that day, month, year. So day, comma, month, comma, year. That is your data that you will get if you do like this. So something like this, employee means you will have 3 data as one record. You have ID, name, department inside one bracket lah. Inside one bracket. Okay. So normally for me, okay, if I want to do this, okay, because when you do your operation schema, when you go for triple, quadruple and so on, it will be very hard for you to access the data. Because you have to know, you have to go back. Even though it's actually 5, but the data is the first one that you have to go back. Or the data is in the middle, you have to go back or go front. So there will be a few steps that you have to do, so it will take time. So what I'm suggesting for the assignment, we go for a pair. But if you want to go for display the output, then you can have like this. Because display the output, you can have many. Easier for you. Okay, but for when you want to access the data later, okay, when you use something like function and relation, I will suggest you to go for a pair. Okay, so later you will see how we are going to access the data. Okay, so if let's say I do Cartesian product like this, employee, ID, name, department, then if let's say I declare a variable called staff of type employee, then actually my data for staff can be like this, where I have 3 records straight away. Okay, not 3 records, 3 data inside a record. So I have ID, name, and department just now. Is it the department? Department just now. So I have 3 like this. Okay, so for me, if your record of data will not be splitting, you want to extract the information as it is, then you go for this one. But if let's say you want to retrieve month only, you want to retrieve day only, you want to retrieve year only, then my suggestion is not to go for this one. Because if you do that, then it will be a lot of steps that you have to do. Okay, so it's up to how you want to retrieve the information. If as a whole data like this, then you can do like this Cartesian product. If let's say you want to take one only, then my suggestion is to go as individually or as a pair. That's all. Okay, so that is actually tuples. Okay, the one that you have learned is actually Cartesian product. Sometimes we call as product only. So if let's say we but normally I will just say as Cartesian product. So the symbol is X. Okay, so this is you have seen before in your during your tutorial. Okay, so Cartesian is actually combine the data. Let's say this one you combine, you have a pair of data. If let's say you have time, normally we try to go for 2 lah, a pair. So you have a pair of data because easier later to represent in our Z schema. So this is something like this, a pair of data. Okay, so this is 1 record, 2 records, 3 records, 4 records, and so on. But the records is in pair. Okay, the records is in pair. So that is Cartesian product. So if let's say just now you do the employee just now, power set of employee for example, then the records is actually in triple because you have Cartesian product ID, name and department just now. So the data will be triple like this. Okay, different. So it's not that you cannot do triple, quadruple and so on. It's not that you cannot do, but the way that you want to assess, you have to make sure that you use domain, range, and then after that another domain, range, all those things. There are a few steps that you have to add. compared to if you use a pair. Okay, so if you use a pair, straightforward, domain range, enough. But when you go for triple, quadruple, then you have to do a few times of domain and range. So it's not that you cannot do. So I didn't say that you cannot do, just that you may take longer steps to get what you want. Okay, you may get what you want is actually the steps that you have to do is longer. Okay, similar like programming. You want to get something, but you may need to write a few more extra lines just to get the correct information there. Okay, so this is the one just now where you use power set. Okay, so this one, just now I put staff equal to employee, only one record. But if you want to have many records, then you just put power set in front. Okay, power set means many records and you have many records. But the record, because you are using Cartesian product, the record consists of 3 data. Okay, the data cannot exchange. Means that the first one must be ID, second must be name, third must be department. Cannot interchange each other. Similar like you save inside database also, you cannot save ID inside name and so on. Then corrupted data will appear. Okay, so same thing here. Your data must follow according to what you define here. Okay, so if ID first, name, department, so ID, name, department, ID, name, department, and so on. If you want to have many records, you just use power set. Okay, normal power set. Okay, but of course, like I told you just now, okay, you can have triple and so on. But in Z schema, we try to go for a pair. Okay, because when you go for a pair, it's easier for you to handle your assessing the data and so on. Okay, another thing about Cartesian product that I just told you just now is actually you can show like many power set, but you cannot show multiplicity. Means that many to many, one to many, one to one relationship and so on. You cannot show using Cartesian product. Okay, you cannot show. So in order for you to show relationship, for example, many to many relationship, one to one relationship, and so on, then you cannot use Cartesian product. Okay, you cannot use Cartesian product. So how to update, how to change that? One of the structure that you are going to use a lot also in your Z schema, we call as relation. Binary relation. Normally I just call a relation. So relation here. Okay. So just now here, employee, this one, power set, something like this. So if let's say you have power set of tuple, a pair of tuple, tuple means a pair of tuple, power set of that, okay, you can represent using one of it as relation. Relation is to represent many to many relationship. So this is where some of you ask me, do we need to resolve many to many relationship in our ER diagram or not? So as I told you, no need, okay, because we have a symbol to represent many to many. So what is the symbol that we are going to use to represent many to many? We call relation symbol. Okay, relation. So relation, okay, also comes from tuple, a pair of tuple. But tuple here, let's say S and T is a tuple, but you have power set outside here. So if it is many to many relationship, you change the whole thing here without power set, remove power set, you just put double-sided arrow here. Okay, double-sided arrow here means relation, so it's many to many relationship. So how do we read this? S, okay, so let's say here, you have S, will have many T, and for one T, you can also have many S. So many to many relationship. So you don't need to use Cartesian product anymore. Okay, you don't need to use Cartesian product anymore. So you can represent many to many relationship using relation symbol, double-sided arrow. So this is the arrow that you are going to use for many to many relationship. Okay, So in this case, for example, end to end or person to month, okay, maybe here you can have, let's say, birthday, for example, not birthday, for example, appointments, okay. One person make appointments in a dentist to meet with the dentist, for example, June and December. Another person also June and December. Maybe another person is January and June. Okay, so the person here, because remember, a set cannot duplicate. You may have two different people with the same name. Okay, two different people with the same name. So maybe, let's say I have Alex here. I have Alex, two Alex, but actually one Alex appointment is January and June. Another Alex may be in June, December. But you have two Alex. But in your set, you are going to represent as Alex only, one data only. Okay, because you remember set, you cannot duplicate data. But in reality, you may have more than one Alex. Okay, so if you have many-to-many relationship, then rather than you go for Cartesian product like this, change this into relation symbol. Okay, relation symbol is double-sided arrow. Okay, so when you go for another name is binary relation. When people say, or questions say binary relation or relation is the same thing. So here is actually using this symbol just now. Okay, so rather than you go here, remove P. When you go for binary relation or relation, remove P. Do not put power set anymore, because this relationship means many-to-many already. Means more than one. So no need for you to put power set, because it shows many already. Okay, if you put many, means double many lah. Means the relationship is many-to-many. After that, you have many of this many-to-many relationship. You understand or not? So we don't want that to happen. So if you want to have many-to-many relationship only, remove power set. Okay, remove power set. Just leave it with this, the symbol here. So means that in your state space, before this, maybe you use Cartesian product. Now you have to check your state space. Okay, what is the relationship that you are having there? Is it many-to-many or many-to-many or not? For now, many-to-many first. You don't learn about one-to-one or ever yet. So this is many-to-many only. So if let's say you have many-to-many relationship, change the Cartesian product to relation symbol. Okay, so that is actually what you can do for your assignment already. Okay, so if let's say I do like this, one maybe staff here will have more than one phone number. Maybe you have one handphone number, office phone number, house phone number, more than one person. And then that phone number also can be shared. For example, office phone number may be used by a few staff. Okay, and then phone, for example, home phone number, maybe one staff here and one staff here stay together, rent house together. So use the same house phone number, for example. So it is many-to-many relationship. So even though you didn't put power set in front, you are going to have records of data for that information. You are not going to have one record only. You are going to have many records of that information. So for example, this one you have these records. So you can have, in this case, I have Philips here. Maybe two different Philips, okay. And then here I have one phone number here, same phone number used by Philips and N here. Maybe inside the same room, extension, same extension, for example. So it is many-to-many, okay, even though no power set, no need power set. So it is still show many records. Okay, so many records. So just use this symbol. This is what we call as relation symbol. Okay, relation operator. Okay, so this is another example just now. For example, appointments. I have two basic type, date and person. This one date, I don't care what is the format of date. Okay, if let's say you want to be specific, then you do Cartesian product just now. But here, no specific format for date, just to say that it is a date. Okay, you can use a date in terms of date, month, year, or month, date, year, whatever, it's up to you. But in terms of this, I don't have the format for date. So I just say as a date only. Okay, so for this one, this is the date, this is a person. So one person, like one date, can have many people make appointments on the same date, and then one person can make more than one appointments. Okay, so if you have that, then you use many to many relationship. Okay, many to many relationship. So this is actually what you have to remember about many to many. Okay, so you have declared your variable relation, many to many relationship. So how are you going to manipulate your data later, especially in your operation schema? Okay, in your state space, you declare your variable that will communicate with your database. Okay, whatever variable that you are declare in your state space, those are variables that you are going to communicate with your database data. Okay, so after you declare your variable in your state space, then you start with your operation schema. Of course, you have your initial state lah. But after initial state, then you start with your operation schema. Your operation schema, normally CRUD, will be using the same symbol, right? The union, backslash for remove. For example, you want to update, will be override, and so on. Will be similar symbol. So you don't have to worry about the symbol. So you have to remember the symbol only. So same thing for binary relation, okay? You are going to use this symbol for update, for removing, and so on. So you can use union, intersection, backslash, hashtag, whatever that you have learned previously. Okay, so the concept will be the same. If you want to add the record or you want to add the data, you use union. You want to remove the data, you use backslash. You want to override, you want to update, you use override symbol, and so on. Okay, so this is actually operations that you can do with your relation. So you don't have to worry do we have another operators and so on. No, you just use whatever that you have learned previously, union, intersection, and so on, with your binary relation. Okay, so if we talk about relation, because it's similar like coordinates. It's similar like coordinates because a pair. Remember just now you see two only inside your declaration, two only. So let's say S relation to T. So two only, S and T. So it is a pair. Okay, it is a pair. So when it is a pair, it's similar like coordinates also. Okay, the way to write normally is similar like coordinates. So the first we call as first. From the bracket, so this is we call as first, this is what we call as second. Okay, similar like coordinates. If you remember when you go for the set, so if you have say a pair, you have to write like this. Okay, and then this will be the first, this will be the second. We call that first coordinate, second coordinate. Okay, first coordinate, second coordinate. But in order for us to make sure that it is different for normal coordinates, because normal coordinate you put comma, normal coordinates you put comma, but for us to make it different from normal coordinates, we are not going to use comma anymore. Okay, we are not going to use comma anymore. So what we are going to use to replace comma, we call that as maplet notation. Okay, the symbol is this one. Okay, you have the arrow. Okay, different. Just now you have double-sided arrow. Different arrow. This one you have line here, then you have arrow one side. So this, when you have this here, this is first, this is second. Okay, this is first coordinate, this is second coordinate. So we call the symbol as maplet notation. Okay, for Z schema, we are not going to use comma anymore. Okay, when you start using relation, actually Cartesian product and relation, starting from Cartesian product onwards, we are not going to use comma anymore. Okay, so we are going to start using maplet notation already. So for maplet notation, you have first and second also. Similar like coordinate. First coordinate and second coordinate. But we didn't show using comma only. Okay, so because comma like normal, like coordinate, longitude, long leg lah. So means that we are not following that. We change the comma to maplet notation. Okay, so when you have maplet notation here, if you change the place, Susie to Eric, is two different data already. Make sure that you know the difference, because first is for all first coordinates. Second is for second coordinate. So if you exchange, it will be different data already. Okay, different people or different data and so on. So when you have maplet notation, you are actually telling people that Eric is mapped to Susie in this case. Okay, Eric is mapped to Susie. So that is what you mean by this statement. Eric is mapped to Susie. So that's why we call it as maplet notation. Okay, if you put the other way around, you put Susie, Eric, okay, means that Susie is mapped to Eric. So maybe this one is different people already. Okay, so that is another thing that you have to know. When you put here, so this is first coordinate, this is second coordinates. Okay, so it says, in this case, Eric is mapped to Susie. So that's why symbol here is what we call as maplet. Okay, maplet notation. So for this one, you don't need to put bracket. For coordinate, you have to put bracket. For the maplet notation, no need the brackets, parentheses, no need. Okay, just use the maplet. So automatically we know this is the maplet notation. So this is the first, this is the second coordinate. Okay? So this is the one that I showed you just now. When you use comma, we call as coordinate, but we are not going to use this anymore. Starting from this week onwards, okay, you have to start using maplet notation already. Okay, for your operation schema, normally for your operation schema. Okay, so if let's say you use the keyword first, okay, for this one, this one normally will be the answer, but rather than in our Z schema, the keyword first and second, we are not really use. Okay, we use a lot of domain and range. Okay, so I just want to let you know that there is a keyword first and second. So your variable, make sure that you don't use the keyword first and second variable. Okay, because first and second is how to say, keyword for you to do in your relation and so on. Okay, but we seldom use first and second, but it is a keyword. So just to remind you, don't use first and second as your variable. Okay, so the one that we are going to use a lot is domain and range. Okay, so this week tutorial, okay, we started with domain and range already. So domain and range similar like first and second, just that first and second only one record. Okay, one record only. First and second is one record. But normally in our database, we are not going to have one record. We are going to have many records. Okay, when we want to have many records, so we don't use first and second. We are going to use domain and range. Domain is to represent all the first records. Okay, domain is to represent all the first coordinates records, whereas range is to represent the second coordinate records. Okay, so because first and second is one record only, so if you want to show all the record from the first coordinates, we have to use domain. If you want to show all the records from the second coordinates, we use the word range. Okay, so the keyword that you have seen before is dom and ren. Dom and ren. Dom is for domain, ren is for range. So if I put dom in front of my records, let's say these are a pair of record, a pair of a few records, pair data. Okay, so if I put dom means I am taking the domain only, the first 1, 2, 3 as my answer. Whereas if I put ren, I will take A, B, C as my answer. Okay, so that is domain and range. So domain is all the first records coordinates, and then a range is the second coordinates records, all the list there. So you list down all the data there. So when you list down, because these are the set, you must put inside curly braces. Okay, these inside the set, you have to put inside the curly braces. Okay, so this is another example of domain and range. So same thing, dom, ran here. But if the data are duplicated, like ran here 2, 2, domain is 1, 1, just make sure that you put 1 only. No need duplicate. Set cannot be duplicated. Data in set cannot be duplicated. So don't put 1, 1, 2 cannot, because 1, 1 is duplicate already. So you have to put 1, 2. No duplication of data in your set. Okay, so same thing for B, same thing for C. So you can use DOM and RAN, DOM and RAN, to show which one of data that you want to access or you want to retrieve. Okay, you are going to use a lot of domain and range later when you start with your operation schema. Okay, your operation schema will use a lot of domain and range. Okay. There are also terms, okay, this is not keywords, this is only terms to show about source and target. Source is actually your domain, whereas target is your range. Okay, so when you want to say subset of this, okay, so if it is source, so we are talking about domain, normally domain. Okay, so you have also, if you are talking about range, we call that as target. But this is not the keyword. This is not keyword. This is only for you to understand. If you want to retrieve information from the domain, okay, we call that as source. If you are retrieving the data from range, we call that as target. But it is not the keyword. The keyword is only first, second, DOM and RAN just now. Source and target, not a keyword. Not the keyword. Okay. So now, in your tutorial 5, there are questions about this symbol already. Okay, so the first symbol that you are going to use a lot also in your operation schema is what we call as domain restriction. Okay, domain restriction is another term that you are going to use a lot in your Z schema, especially in your operation schema. So domain restriction is similar like you search. If you found the data, you display the data according to what you search. Okay? So let's say I am searching this data, found it, display the result of that data. Okay, so when you see the word domain, you are searching the domain data. Okay, you are searching through the domain data. Means that the data that you search is domain, but the result is domain mapped to range means a pair of data that you found. Okay, so but your data that you search is from domain column. Okay, from domain column. So if let's say I want to search, let's say this is my data. This is my record inside my database. So if I want to use domain restriction, this is the symbol, the arrow like this. Arrowhead, the arrowhead like this, pointing to the left. Okay, pointing to the left. Why left? Because domain is on the left. You have coordinate just now, right? First and second, right? So domain is the first coordinates, range is the second coordinate. So first coordinates is domain. So that is the first one. So the arrow point to the left. Okay, point to the left. And then this is the record of the data that you want to search. Okay, this is the record of the data that you want to search from the domain. Not from the range, from the domain. Means that if the domain is ID, the data that you want to search must be ID also. Okay, if the range is name, let's say ID name, ID name, Your domain is ID. So the data that you want to search, if you are searching from domain, then it must be ID. Okay? And then if ID is actually inside the whole data, then let's say this is the ID, this is the name. So produce the result as this one. Both domain and range as the result. Okay, both domain and range as the result. This is domain restriction. Okay, this is domain restriction. So if you have domain restriction, okay, so this is another one, another example that you can refer. If let's say your searching is not there, okay, means that the ID does not exist, for example, the result will be empty set. Okay, the result will be empty set. You can do searching for more than one. Okay, you can do searching more than one. Okay, then the result will come out if both appear. Okay, if one appear, one only lah. Okay, and then something like this also. You can do like this. Okay, if you have more than that, then you will produce the output more than that. Okay, so this is domain restriction. Okay, so you are looking at the domain data. Okay, of course, when you are looking at the domain data, you can also looking at the range data. So domain we call as domain restriction, whereas for range we call as range restriction. This is another one lah. You can have a look also lah. Range restriction. Wait okay. I just want to show you something This one I put rank in front This is domain restriction, right? Okay Just now the answer will be something like this, right? 2 maplet B, right? For this one if you do this domain restriction, the answer is 2 maplet B. But sometimes you want to produce let's say ID. You search ID, you want to produce output as name only, not ID and name. Here will be ID and name. So if you want to produce output as name only, you can put another domain or range in front here. Okay, if let's say the name is ran, then you put ran in front. Okay, that is another way that you want to show the result. Later I will show you using Microsoft Word. Okay, so this is if let's say you have double, same thing here. Okay, you have ran and domain or domain follow your what you want follow what you want. I will show you later also. Okay, another one is range restriction. Just now you search domain, now you search through range. Let's say I have ID name, I search through name. Okay, rather than ID, I search name. Okay, so range So same way, just now the arrow pointing to the left, but for range is pointing to the right. Okay, range is pointing to the right. This one, the way to right. Don't get confused. Put everything in front. No, it's different way of writing. So you point to the right like this. So the data that you want to search also must be range data, not domain data. Range data. So meaning that if let's say I have ID to name, the data that I want to search is name. Okay, so I have to put name here. Then I have the record. The answer will be similar to domain restriction just now as a pair. Okay, a pair of record and so on. Okay, so this is range restriction. Okay, range restriction. So for range restriction, you are doing same like just now. If the data does not exist, empty set. You can also do more than one update, checking or searching. And then you can also do like this. So make sure that it is pointing to the right. Okay, pointing to the right. Okay, and then same thing like just now. If let's say you want to produce, I search name, I want to show the ID only, for example, then I can put the word DOM in front. Okay, the word DOM in front here. So mean I have two data, okay, maplet but I want only the domain to appear. Then I put DOM in front. Okay, I put DOM in front. Then same for others same for others. Or you want to take a few minutes break first? Or want to proceed? Take a few minutes Until 11 we will proceed again.
我是叫还没有哦，都一样。啊？八零四，阿炳。4858 36，就这样子。啊，对。奶茶切8块，加6块。丢红线的这个月老，丢红线的是吗？哦，然后丢，啊是丢红线是哪里呢？把它是丢上去一个，丢在一个树上。
Anybody else will sign your attendance?
Invite friends, get
Check your summary report. How many of you below 80 already? Ha? 1, 2, 3, 4, 5, 6.
老外公。
管赚了2个。
Week 5 already below 80 啊？
我没有去玩哎。
So make sure that if these people are inside your class or are here, okay, make sure that you let them know. Champagne, the rest Already apply 啊？
有啦，你不是没去？
这个老师讲
晚上有吗？我早上有呀，晚上的。
Yeah, for others, if you are here, ensure that 80 and above, by week 12,
我跟他讲哦，
week 13 is Monday, week 13, cannot do anything at all. So you have to start appeal already. The money will come out on Monday. So if the money came out already, even though for me I cannot do anything except go, you have to feel and you will.
哎呀，没事啦，七十
If
九，
let's
下个礼拜就回来
say
了。
before that, you can like you communicate with the lecturer and so on lah. So they can if they are okay with that lah. Okay, but after that we cannot do anything. You have to justify why you get
金嘛，他就拿。
Okay, so please let these people know. Okay, and if you are here, please make sure that you try to get a number for your attendance. Less than 80%. The rest will be okay. I have only for my subject. For other subject, I don't have. Okay, let's proceed. Let me show you in Microsoft Word first. Okay, so last week you should already done your state space schema. Okay, let's say your state space called staff, for example. There may be what you did. Okay, my suggestion is for you to find one primary key. Okay, one primary key from your record lah. Okay, let's say staff ID is the primary key. So you create variable maybe called staff ID. Okay, power set of ID, for example. Okay, so when it is a primary key, you just do one enough, because this is to show this is your whole records inside your database. Okay, then maybe just now you may have what you did last week, you do Cartesian product. Let's say staff name. Okay, maybe what you did is ID, Cartesian product to name. See power set power set. There may be another one is email. For example, staff email. Why got this? Staff email. Okay, power set of ID, Cartesian product to email. Ayo, this one not relation yet lah. Ayo, that's okay lah. This one not relation yet. Relation is this one cannot be relation. This one should be function. I haven't teach you function yet. That's okay. Okay. So what you did last week, you look at the common type. So this is a common type, right? The same type, okay. So if you have a record like this or a declaration like this, okay, Cartesian product, okay, this is first coordinate, this is second coordinate. This is first coordinate, this is second coordinate. First component, second component doesn't matter lah. You want to use the word coordinate or component doesn't matter. So first component, second component, second component. Okay, So when you have first component, just now you learn about domain, right? Second component is range. Why I go for domain and range? Because I have power set here. Many. So I will go for domain and range. Okay, domain and range. So here, if I want to represent ID here, I will put DOM, staff name, okay, equals to DOM, staff email. Okay, so I have done with this. Okay, but I still have another one here, staff ID. Staff ID only one. No domain, no range. So I will just put equals to staff ID. Okay, so I cover all already. Okay, here I have name, email. Not the same, so I cannot do anything. Let's say I have one more variable called login, for example only, login, where I have power set of email, Cartesian product to password. Okay, let's say I have this. Assuming. But you can have different. This one is for our exercise only. So, here email, same type. Here email. Here also email. Okay, so same type. So you have to tell inside your state space that this is the same type. So what you have to do, okay, this is the second component. Second component we call as ren. Okay, second component. So we put ren. Our variable is staff email equals to DOM, login, for example. Okay, so this is something that you should already started with your state space last week. Okay, so you should already done something with this. Some of you, okay, can I press enter? Okay. Some of you maybe you have done. This one cannot be. I cannot insert already. Wait, cannot be. Wait, let me cut this one. This version. You must have enter first and then you must have a space. Assuming that you have done your axiomatic definition, what is okay lah, total staff, for example, in a company cannot exceed 20, for example, only let's say total staff, in my company I can have only 20 only, because not enough, the room is small, for example, so I can have maximum 20 staff only. Okay, assuming I have this. Some of you may have axiomatic definition, some of you might not have axiomatic definition. So assuming that maybe some of you have done axiomatic definition for your part. Okay, so you want to say that in your state space that the staff inside your system cannot exceed 20 staff here. Okay, so how are you going to do that? Okay, so here your primary key is your staff ID. In order for you to know how many staff that you have, you use hashtag. Okay, staff ID. You can put less or equals to total staff. Like that. So when you do your state space schema, whatever general constraints, general condition that you want to show, okay, please add inside your predicate part here. Okay, please add inside your predicate. This is example only, if let's say you have this lah. If don't have, then you don't need to do this one. This one I just want to show that there are things that you can add, okay, inside your predicate part, other than domain and range. Okay, so this is about your Cartesian product. Okay, let's say, okay, you haven't learned about function yet, but I want to show you, assuming that I want to change to relation, or relation, many to many. Assuming for now, I want to change to relation. So, if I have this, what I need to do here, I remove the power set. Then the Cartesian product, I use this one. Binary relation symbol. Here also, I use binary relation symbol. Okay. For now, of course, we didn't consider many to many. Actually, shouldn't be many to many lah. But if you want to have many to many, then you change to like this. Remove the power set. Okay, remove the power set. But for the staff ID, because this is primary key, you remain it except the Cartesian product that you have removed the power set. The rest will be the same. You don't have to do anything. Whatever that you have in your predicate part, okay, whatever that you have in your predicate part, you remain the same. No need to worry, is it going to be domain or you have done with the Cartesian? It will be the same thing. Okay, you have done with the Cartesian, it will be the same thing already. Okay, so this is for relation just now. Okay, just now you have looked at the you have looked at the domain and range restriction. Okay, you know right why we do something like this? We do all, doesn't matter. You do like this, you know why you are doing like this, right? You are going to link your data together. Means that if let's say I use ID, I can get the name. I use ID, I can get the email. I use email here, I can get the password also. Okay, so this is what we call as Cartesian product. Or same thing here lah. I use ID, I can get the name. I use ID, I can get the email. So I am linking the data together. Okay, so this is what I mean by relation or a Cartesian product relation and so on. So just now you see about domain restriction. So the symbol for domain restriction is under relation part here. So you have the arrow here. Okay, this is domain restriction. This is range restriction. So assuming I will take one here. ID to name. Okay, so my database should be like this lah. Actually, in my database, I will have so let's say ID, okay, name, for example, so I have whatever example lah. Okay, so this is the ID. This is the name. Okay, so this is what actually we have inside our database. Okay, if we do this, so the domain, this is domain, this is domain. Name will be the range. Okay, because we are doing like this. Okay, so ID. So these are the ID, name, these are the name. But this table, we call as staff name. Okay, that's why our variable is staff name here. Okay, staff name here consists of ID and name, So the whole table here we call as staff name. Okay, so when, let's say you want to search, I may have, because I have many to many, so in this case, I may have another one, okay, for example, okay, so I may, because I have many to many, maybe here will be AAA, I'll do AAA here, okay, so because for now, we are concentrating of many to many in this relationship, but actually, real life, this is wrong, okay, because ID cannot be duplicated, but I just want to show you how many to many works. Okay, so assuming that even though this is incorrect because ID cannot be duplicated, but I just want to show many to many relationship here. Okay, so this is my table called staff name, consists of ID and name. Two column. One column domain is for the ID. One column for range is actually to represent the name. Okay, so if I want to search, I ask you, do you have ID number A111 inside your staff list or not? Okay, so you want to search for that data. So you can use domain restriction because I'm asking ID, so ID is domain. Okay, ID. I ask you, can you give me the staff name with the ID A111? Okay. So you are asking for A111 ID. So I want you to provide the output for that. So the ID is domain. Then you want to search the domain. Then you go for domain restriction. Okay, so how to do that? Okay, so you put inside the curly braces A111 just now, because this is the one that I want to search. Okay, and then domain restriction, and then my variable, I don't need to list down, so I use the variable staff name here. Like that, in order for me to search for it. So I will get, okay, so from here the result will be, because I have two, A11 and A11 here, so I will get two results. A111 maplet. Okay, this is a maplet symbol. Okay, and then AAA. Another one is A111 maplet. Let's say small letter lah, all small letter lah. Okay, Y. Like that. Okay, so this is what I will get. Okay, this is what I get. Of course, this one I will use like data. But if let's say you use variable, let's say I declare a variable called I declare a variable called ID input of type ID. Okay, so I declare a variable called ID that I want to search. Okay, the ID is input into my system, and then I want to search this ID. So how to do this? Okay, you do the same thing also, but rather than you put in front here A11, then here will be the ID question mark, something like that. Okay, so this is the searching data lah, if you want to have like that. If you don't want to have curly braces, also can. Okay, so it's up to you. So this is actually how you search the data from domain. Let's say, because I just want to know the name, right? I don't want the ID again, because I asked you, can you give me A111? I don't want to know the ID because I know the ID. I just want to know the name. So the name here is range. Right? It's range, So rather than I go for this one, then I add another one in front here. Okay? So this I copy, easier. Show the difference. Okay? So I put ran bracket ID like this. Okay, so actually what you get, you will have ran of this, and then the last one that you get will be AAA and YYY, like that. Okay, if you put ran in front. Okay, so this is actually if let's say you want to produce output lah. Okay, you want to produce output, you don't want the ID again, you want only the name. So the name is range, then you put ran in front. Okay, so if you want to go for this is domain restriction. If let's say I want to go for range restriction, so I want to search name. So staff name just now. How to write? Range restriction is this one. Okay. Then let's say the name is what FFF, for example. Okay. So what you will get is A123 FFF. A123 maplet FFF. Okay? So if let's say you want to know the ID of that person, you just do, because ID is domain, then in front here you put DOM bracket the whole thing. So what you will get is DOM, this one DOM of this one. Okay, so from here, domain is A123 as the answer. Okay, so this is if, let's say, you want to go for domain restriction and also range restriction. Okay, so that's how you do searching for your data. Okay, searching for your data. Any question at here? All okay, yeah? Understand? Okay, so after you have done with domain restriction and range restriction, those are searching the data and produce the result. If no result found, it will be empty set. You can also do another one, what we call as anti-restriction. Okay, anti-restriction. So anti-restriction, another name is subtraction. Okay, so it can be domain or range anti-restriction. Okay, domain anti-restriction or range anti-restriction. So the difference between domain restriction and domain anti-restriction, they use similar symbol, just that the anti will have the line in the middle. Okay, the anti symbol will have the line in the middle. Another one is, just now you search, you produce the one found, but for anti-restriction, you remove that data. You found that data, you remove it. Other than the one that you remove, those are your output. Those are your data after the update data. Okay, so you remove the data, then the latest data is actually without the one that you remove. So that is anti-restriction. For example, the way to write same. If it is domain, pointing to the left. If it is range, pointing to the right. The way to write will be similar to domain restriction or range restriction just now. Just that the symbol is got line in between. So if you do something like this, you are searching the domain data, found it, remove it. The latest data will be without that the one that you remove. That is anti-restriction. Okay? So same thing for range restriction. Okay? Pointing to the right. Okay? So you remove B, the range data. Okay? You remove 2B 2B here. Then left with 1A or 3C. Okay? The one that you remove will not be inside your latest output. So this is actually similar to the concept of backslash just now. Remember, you learned about backslash to remove the data. Backslash, if you use the relation, you need two data, right? Domain and range. Okay, then you can use backslash. But here, range anti-restriction or domain anti-restriction, you don't need both data. You can get only using one data, domain only, or range data only. Okay, so then you can remove the data. But if, let's say, you want to go for backslash, you need both domain and range data to remove. Okay, so that is how you use anti-restriction. Another symbols that you are going to use a lot also, we call as relational image. The symbol is a crescent symbol, anak bulan. So the opening and closing. Okay, so relational image similar like domain restriction. Similar like domain restriction. The only difference is, for relational image, you found the result of domain. You produce only range data. You don't show domain result. You give range data only. Compared to relational image, compared to the domain restriction just now, you have both domain and range. Here, when you go for relational image, you search the domain, your result is range data only. Okay, but the way to write, similar to range restriction, means on the on the right side. Okay, domain restriction on the left side. Relational image on the right side. But the concept is similar. Okay, so you search the domain data, Okay, you search the domain data, but the output will be range data only. Okay, similar like searching lah. You don't need the searching. I ask the ID, I don't need to show the ID because I know the ID already. I just need the name. Okay, so rather than I go for domain restriction, I can go for relational image. For example, just now, this one, this one, right? Okay, rather than I go for this, okay, why not I change this to staff name? Okay, then I use the relational image, this one, okay, inside here I put ID, for example. Okay, so it's similar like this. I will get the answer as this one. Okay, so this is actually similar like this one. Okay, so this is relational image. Okay, so you can find from relation also these two. Okay, so same like this. Okay, you search on the domain data, but the result will be the range data. Okay, the result will be the range data. Okay, so this is relational image. Okay. So if let's say the data is not found, empty set, you can also search double like this, okay, or you can search your variable like this. Okay, so the concept is similar like domain restriction for relational image. Okay, so this is the one that you do with your domain restriction just now. Okay, the concept is the same as this one. It's the same thing. Okay, these two will produce the same result. So if let's say in your exercise whatever, you can choose either one, whether you want to use domain restriction or you want to use relational image. But remember, relational image only used to search the domain data only. Okay, the domain data only, not the range data. Only the domain data. That is relational image. Okay, inverse. Okay, inverse is another symbol that you have to remember. Okay, so inverse, the symbol is actually I will show you the symbol later. So this one, the symbol is this one. Okay. So what is actually the use of inverse? You are actually swapping. Domain become range, range becomes domain. That's all. Okay. You are swapping the data. Domain becomes range, range becomes domain. Okay. So this inverse operator is used when, for example, just now, when I want to search ID, no problem. I'm using relational image, right? Using relational image, no problem, because I search through domain. But if let's say I have the name, I don't have the ID. So I want to use relational image. Okay, I want to use relational image. So rather than I do a lot of things, then I can just use one operator here, inverse, to swap. My range becomes domain, my domain becomes range. Okay, so when you do that, your data, all the range data, there's now ID name, right? When you use inverse, become name ID. Okay, the domain become name, the range becomes ID already if you use inverse. Okay, for example, let's say just now, this one, right, we use the domain, right? Okay, so this one is use the range restriction, range restriction. I have this. But if I want to use the relational image, staff name. See, staff name. But inside my relational image here must be domain. Okay, must be domain. But my real data is this one.
靠这算法，其实我还是接受个7条。
Okay, inside the crescent or bulan sabit here, okay, relational image, you must put domain. So in our case, domain is ID. But let's say I give you, I have this name. What is the ID of this person? Let's say, so I give the name. I want you to give me the name. Sorry, I give the name. I want you to give me the ID. Okay, so the name is the range. So I cannot simply use like this. Because for the relational image, inside here must be domain. So how to solve this? You put inverse in front here. This one. Okay? So when you put inverse, what it means actually, this is equivalence to is equivalent to this one, name. This one become ID already. When you do inverse. So it's swap. Domain becomes range. Range becomes domain. So when you want to search, okay, then you can do this one. Then you put this one. For example, I want to search FFS. For example, this one. Then I close this one. Then the answer that you will get will be same as previous something like that. Okay, so that is inverse. Okay, inverse means you swap. Domain becomes range, range becomes domain. Okay, so this is actually used later when you want to produce the result. You don't have domain result, but you have range result. For example, let's say you link to your friend. Then after that, your friend is range. Okay, then you want the domain. So it's very difficult. Then you maybe need to inverse and so on. Okay, maybe you need to do some inverse here and there to show that you get this data or you get this data and so on. Okay, so you can do inverse operator. Okay? Any question until here? Okay, so for this question, for this actually slide is actually related also where you have ring Z, but when you inverse, it will become Z rings. Terbalik. Okay, so it will be swapping. Domain become range, range becomes domain. So for the inverse, this is the inverse operator. Okay, this is the inverse operator. Okay, so if let's say you have this just now, similar like I showed you just now. Okay, you have the range restriction just now, and then you put DOM, the answer will be there. Then if you can also use the inverse operator like this, you do searching like this. So when you do inverse operator, the data will be swapped. Okay, data will be swapped. Then you can do searching like this. Okay, data will be swapped. Then you can do searching. Because for the relational image, remember, it is only the domain data to be searched, not the range data. So you have to swap the place for you to search if you want to use the relational image. Okay, if you want to use the relational image. Okay, so this is the same thing also. If you inverse, let's say you have name and phone, you inverse, then become phone to name, become phone to name lah. Inverse lah. Okay, inverse the data. Okay, the next one is override. Okay, you have seen also last week during the lecture about override. Okay, override symbol. Override is, for example, you want to update the data. Okay, you want to update the data in your database. So we are going to use override symbol. So override symbol is this one, circle and plus in the middle there. Okay, so this is override symbol. So override is you are actually override the old data with the new data if the data that you want to override does not exist. Okay, it will add into your database. You understand or not? If the data exists, it will override the data. But if the data does not exist, it will add the data into the database. Okay, so but don't really use override just to add the data. Normally, to add the data, we use union. Okay, but override is something like sometimes you didn't realize that the data does not exist, but you thought it already exists. So that's why when you do operation schema, when you want to override, you have to do checking whether the data is exist or not, so that you don't add record accidentally. Okay, because when you want to add record, normally you use union, then you are checking is the data must not exist yet. Okay, but if you want to override, the data must exist so that you can update the record. Okay, if the data does not exist, it will add the record, but it will not really good related to your system, because in order for us to add the record, we use union. But now, because the record does not exist, means you didn't do the pre-checking or precondition. Okay, so you have to look into all this to make sure that you produce a very good operation schema later. Okay, so but of course override, like I told you just now, is to override. That means that you update the old record. But if the data does not exist originally, it will create the record for you. But for our Z schema, make sure that we don't add the record. So how to make sure that we don't add record? We do precondition checking. So if you want to override the record must exist in your database. Then you are not adding another record in your database. Okay? Because if, let's say, for now, many to many, no problem. But when it comes to function, okay, where you are going to go for primary key and so on, you cannot duplicate data. So if you didn't do the checking, you may duplicate the data. So that's why, make sure that your precondition in your operation schema, look at every corner that you can think of in terms of your precondition. Okay? So that is override. Okay. Another things that you may also do in your relation is what we call as composition. Okay, so you are merging two relations, okay? So by combining pair that share a matching component. If not matching, then you didn't do lah. Okay, so for example, I have two basic type here, person and room. And then I have has phone, person to Z, and then phone in room Z to room. So means that the range of the first relation and the domain of the second relation, if match, you can do composition. Okay, if match, same type and so on, same type. If match, you can do composition. So how to do composition? Okay, let's say this is the story lah. Let's say you are actually stay in, there's a phone inside the hotel room. Okay, and then that room is, let's say the room is A306, then the phone extension is this number. And then you are staying in this room. So when we want to see here, we are going to say that, okay, you are actually using this phone in this room, right? So we are saying that you are in this room. So we want to eliminate the phone number here. Okay, because it's the same thing. So you are telling that this person stay in this room. Okay, rather than this person use this phone, this phone is in this room. So why not you just say this person is in this room. So you skip the middle part. Okay, make sure that, okay, when you want to skip that, the middle part must be the same. Matching, matching pair. If not matching, you cannot do that. So we call that as composition. So how to do that? You just write like this. Fat semicolon. We call as fat semicolon. Fat semicolon is not the same as semicolon from your keyboard. This is a special semicolon from the Z. Okay, so this fat semicolon is the composition symbol. When you do like this, the answer, your output, will eliminate the full number just now. So there are cases like your assignment, for example, that you want to say that this one, you produce this. This one become input for this one, right? So you say that this is actually linked to this. You can do that if you want. Okay, but if let's say two different operation schema, two different people doing, no need lah. But if you are the one who's doing all, the same thing all, you can do composition. Okay, so that is what we call as composition. Okay, so this is another example lah. Okay, phone department. So make sure that here phone, here also phone, range of this one and domain of this one, same type. Not different type, same type. Different type cannot, it's not matching. Different type, even though it's phone number also, but type here is PH, here is phone, two type already, because different basic type. So you cannot combine. If you want to combine, make sure that it is the same type. Okay? And then you do the composition like this. Okay, the composition like this. So this composition, if let's say there are cases where you don't want the data in the middle, is you can eliminate the data in the middle. So you can just use the composition. Okay? So let's look at this exercise. So I think this is the last one for today. So if I do this, what is the answer for this one? What is the answer for this one? The A here. If I give you this one, what is the answer for A here? This one using, what is the symbol here? What is the symbol here? Relational image, right? You are looking at the domain data. So do we have 3 in the question here? Yes. So the result will be only the range data. So the answer will be Wednesday, WED lah, right here. The answer will be WED only for this one. Okay, how about this one? B. This is normal, backslash. Okay, backslash that you have learned before. But because this is a pair of data, do we have this inside here or not? No, So what is the output for this one? What is the result of this one? You want to remove this one. Okay. What is the result for this one? Okay. So the answer will be remain all this one. Yeah. The output will be this one. Because you want to remove but not exist. So the actual result will remain all this. Yeah. You write down your answer yourself. This one override. Okay. So Adam 23, Cindy 22. So I have Susie 25. Adam become 23. Lim 24. Then I will add Cindy 22 as another answer because not exist in my data. Okay. So Adam will be 23. Lim 24 remain. But I will add Cindy 22 as the fourth data or record inside my database. Can you can write this on your own No need for me to write on the screen Can Boleh Okay, D here inverse Inverse means swap. So Malaysia 060, Australia 061, India 091, Singapore 064. Terbalik ah. So domain will be the country. 060 is our code, right? Okay, so will be the range data. Okay, range restriction range restriction, searching for range data with 30. You have April 30 as the answer, June 30 as the answer, September 30 as the answer, and November 30 as the answer. So you have 4 answer for this one. And the last one here, this is domain anti-restriction. We are going to remove the data. So 064, 061. Okay, so the last data will, the answer will be 091 India and 060 Malaysia. Can I? Can get it I will write the answer here. So assume you can take notes on this. Okay? Anybody who has problem to get the result of the answer just now? All okay, Actually, I have the answer here. I will show you. One more thing that I want to show you, the symbol just now, Cartesian, not Cartesian, composition. Composition, the symbol is, where is it? Where is it? Cannot see it. Should be here. Why don't have? This one, sorry, this one. This one, composition symbol. This symbol, So you have to use this symbol, composition, not from the keyboard, composition just now. Okay, override, of course, this one, override. This is override. Okay, so these are the symbols that you can find from the relation symbol. Okay, this one we are not going to use. A relational ID also. No need, all these not really use. The one that we use are this one. Okay? Any questions until here? Any question until here? Anybody who has problem to get the answer just now? Okay? So this symbol that you learned just now, relational image, whatever, you are going to use a lot when you start with your operation schema, especially like precondition checking. Okay, you want to remove or update the data means that you want to update the data, remove the data, you have only the domain and so on, and then you can actually use all the symbol. Okay, and then one more thing before I end the class. Inside your Google Classroom, I already added to you or give to you the library system. That's why your assignment, you cannot do library system. I just want to let you know that some of you, maybe you want to do, let's say, account, wherever you have staff account, student account, whatever, different account. But you may have generic one same for all, but different for others, right? Similar like inheritance, but we don't have inheritance in our Z schema. So my suggestion is you can do separately like this. Maybe one for general, for example, and maybe another one is for each individually. And then after that, you can combine into one module like this. So these are actually small state space. This is also state space. Book details here, book category here, overdue are actually state space. So this state space, you separate into smaller state space. So for the end state space, your state space, one big module, then you combine like this. This is your big state space. So where you combine all the 3 smaller state space just now. Okay, this one, you see, is to link. Okay, what I am showing here, I have book number here. I have 3, same for all, same, So book number I am showing same. So when I want to do this, I don't need to do everything again this one. I don't need to take everything. So I just take one enough. Maybe I just take, here has title, book number, dom. So I want to link has title. No need to take all. Then I want to link, because book number, I want to link with book category. So I just take one of the variable here of book number also. Same variable. So you can just do, for example, like this. Okay? And then I link already book details and book category. So now I have overdue in this case. So how to link book number also? Okay, so you can link with book title, book detail or book category, because you are linking these three together. So why not, maybe you just take one, maybe overdue books here, of type book number. You link with the, for example, book category. Okay, borrow books, for example. So now, when you do this, you are actually combining these three together already into one state space by using this simple variable here. Okay, if you do this, it's individually inside that state space. Okay, here individually inside that state space. But now you want to link this state space with this state space and this state space, then you can do something like this. Okay, later you look again. This is inside your classroom already. I already added here. Okay, then you do your initial state. Another one is, you will see that here, just now you learn about relation, double-sided. Here this is function. Actually, I will explain next week about function. So for this one, you will see also I give you sample of operation schema. You have to look down here, example, operation schema. So some of you want to actually link with your friends operation schema, with your module, your friend's module. So if let's say my module is user, if I want to remove staff, there will be an update to my database. So that's why my module is user, I will have data from my module. Maybe also because I remove staff, okay, there will be an update to reservation. Maybe the staff resigned, so he already reserved some book in the library, so I have to remove his name from reservation also. Then reservation is my friend's module, but because of I removing the staff, I need to update his database also. So I need to make sure that his database also will be updated with delta symbol also. But maybe also, okay, I'm not, when the staff wants to resign, there must be no books borrowed, for example. No books borrowed means have to return all books. So I just want to check only whether got books or not from borrowing, for example. Then no update in database, for example. So I use, maybe borrowing is another friend. Okay, then no update for his database. So I use Z notation. Okay, so from here you are linking a few modules from your friends into your operation schema. So this is the one that, remember when you ask me, is it under me or under your friend? This is the one that you have to check whether this operation schema should be under you or should be under your friends. Okay, so because if you under you, you have to make sure that you check all possible modules involved in that operation. Okay, so you do like this. Okay, another one that I want to explain to you just now about the Cartesian product. Wait, or something like this. Okay, this is the one that you want to produce output like this only. Cartesian product. I just want to have 4 only. Other than that, I don't want to produce. So on the screen, I can use display Cartesian product like this. So then I just, this one is the inverse. Inverse. Then now you already learn about inverse. Try to look at this library system, whether you understand or not. Why we have this and so on. Okay, I try inverse and so on. But of course, I know some of you still, I haven't teach you how all this thing yet. But it's actually, if you want to use Cartesian product, you can. Quadruple, whatever, how many you want, no problem if you want to produce the output. But if you want to retrieve the data, my suggestion is to go for 2 only. Okay, but produce the output, no problem, you can do like this. Okay, so this is the Cartesian product. Okay, the rest is okay lah. You can have a look lah at this. Okay, so I think that's all from me lah. Any question before I end my class for today? Oh, okay ah. So this one no need for me to put inside Google Classroom lah. I don't want. You already got the information right? No need for me to put. So I close it lah. I will save it. Okay.